The English Electric Lightning is a supersonic fighter aircraft of the Cold War era. It was designed, developed, and manufactured by English Electric, which was subsequently absorbed by the newly formed British Aircraft Corporation. It was then marketed as the BAC Lightning. The Lightning was the only all-British Mach 2 fighter aircraft. The Lightning was used by the Royal Air Force and the Royal Saudi Air Force. Although it was the RAF's primary interceptor for more than 2 decades, it was never required to attack another aircraft. The Lightning is powered by 2 Rolls-Royce Avon turbojet engines in a unique staggered stacked installation in the fuselage. The Lightning was developed to intercept increasingly capable bomber aircraft, and thus has exceptional rate of climb, ceiling, and speed. Pilots have described flying it as being saddled to a skyrocket. This performance made the Lightning a fuel-critical aircraft, meaning that its missions are dictated to a high degree by its limited range. Later developments provided greater range and speed along with aerial reconnaissance and ground attack capability. Following retirement in the late 1980s, many of the remaining aircraft became museum exhibits until 2010. 3 Lightnings were kept flying at Thunder City, in Cape Town, South Africa. In September 2008, the Institution of Mechanical Engineers conferred on the Lightning its Engineering Heritage Award at a ceremony at BAE Systems site at Wharton Aerodrome. Development origins. The specification for the aircraft followed the cancellation of the Air Ministry's 1942 E-24 supersonic research aircraft specification, which had resulted in the Miles M52 program. W.E.W. Teddy Petter, formerly chief designer at Westland Aircraft, was a keen early proponent of Britain's need to develop a supersonic fighter aircraft, and proved his point when trials between an RAF Gloucester Meteor F4 and an English Electric Canberra demonstrated that Britain's current air defences would be entirely unable to intercept a bomber travelling at an altitude of 50,000 feet and at a speed of Mach 0.85. In 1947, Petter approached the Ministry of Supply with his proposal. In response, specification ER-103 was issued for a single research aircraft, which was to be capable of flight at Mach 1.5 and 50,000 feet. It was apparent that the aircraft's wings would need to be highly swept in order for an aircraft to attain such a high speed. English Electric decided to adopt an angle of 60 degrees in order to test the design of both the wing and the tailplane and to assess handling. Short Brothers were issued a contract to produce the Short SB-5, a low-speed research aircraft. The SB-5 was developed so that different wing sweep angles could be assumed by the single aircraft. An assortment of tailplanes and wings were supplied and could be installed in order for their flight performance to be evaluated. The Royal Aircraft Establishment was notably skeptical of Petter's swept wing concepts, however. Following the first flight of the SB-5 on 2 December 1952, the trials performed demonstrated the choice of a tailplane and a 60-degree wing sweep proved the design principles to be effective. Aerodynamic data produced from the SB-5 flights and wind tunnel testing helped shape the emerging ER-103 design. In 1949, the Ministry of Supply had issued Specification F-2349, which expanded upon the scope of ER-103 to include fighter-level maneuvering. On 1 April 1950, English Electric received a contract for 2 flying airframes, as well as 1 static airframe, designated P-1. Following the resignation of Petter, Freddie Page took over as design team leader for the P-1. From 1953 onwards, the first 3 prototype aircraft were hand-built at Samlesbury. These aircraft had been assigned the aircraft serials WG-760, WG-763, and WG-765. In May 1954, WG-760 and its support equipment were moved to RAF Boscombe Down for pre-flight ground taxi trials. On the morning of 4 August 1954, WG-760, piloted by Roland Beaumont, flew for the first time from Boscombe Down. 1 week later, WG-760 officially achieved supersonic flight for the first time, having exceeded the speed of sound during its third flight. During its first flight, WG-760 had unknowingly exceeded Mach 1. Due to position error, the Mach meter only showed a maximum of Mach 0.95. The occurrence was noticed during flight data analysis a few days later. While WG-760 had proven the P-1 design to be viable, it was limited to Mach 1.51 due to directional stability limits. On 9 June 1952, it had been decided that there would be a second phase of prototypes built to develop the aircraft towards achieving Mach 2.0. These were designated P-1B, while the initial 3 prototypes were retroactively reclassified as P-1A. The P-1B featured extensive alterations to the forward fuselage and refinement to the inlet cone that regulated airflow into the engine inlet. In May 1956, the P-1 received the Lightning name, which was said to have been partially selected to reflect the aircraft's supersonic capabilities. On 25 November 1958, the P-1B became the first British aircraft to fly at Mach 2. The prototypes were powered by unreheated Armstrong Siddeley Sapphire turbojets as the selected Rolls-Royce Avon engines, which would power subsequent production aircraft, had fallen behind schedule due to their own development issues. Due to the limited internal space of the fuselage, the fuel capacity was relatively small, giving the prototypes an extremely limited endurance, and the narrow tires housed in the thin wings would rapidly wear out. Outwardly, the prototypes looked very much like the production series. They were distinguished by the rounded triangular intakes, short fins and lack of operational equipment. Production. The first operational Lightning, designated the F-1, was designed as an interceptor to defend the V-Force airfields in conjunction with the V-Force airfield's own last-ditch Bristol Bloodhound missile defenses from enemy nuclear-armed bomber attack long enough for the also nuclear-armed V-Force bombers to take off and get clear of their airfields. Airfields which, along with the dispersal airfields, would be the highest priority targets in the UK for enemy nuclear weapons. To best perform this intercept mission, emphasis was placed on rate of climb, acceleration, and speed, rather than range. Originally a radius of operation of 150 miles from the V-bomber airfields was specified, and combat endurance. It was equipped with two 30mm Aiden cannon in front of the cockpit windscreen and an interchangeable fuselage weapons pack containing either an additional 2 Aiden cannon, 48 2-inch unguided air-to-air rockets, or 2 de Havilland Firestreak air-to-air missiles, a heavy loadout optimized for damaging large aircraft. Missile guidance and ranging, as well as search and track functions, mainly were provided via the Ferranti AI-23 onboard radar. The next 2 Lightning variants, the F-1A and F-2, were steady but relatively minor refinements of the design. The next variant, the F-3, was a major departure. The F-3 had higher thrust Rolls-Royce Avon 301R engines, a larger squared-off fin and strengthened inlet cone allowing a service clearance to Mach 2.0. The AI-23B radar and red top missile offered a forward hemisphere attack capability and deletion of the nose cannon. The new engines and fin made the F-3 the highest performance Lightning yet, but with an even higher fuel consumption and resulting shorter range. The next variant, the F-6, was already in development, but there was a need for an interim solution to partially address the F-3's shortcomings. The F-3A. The F-3A introduced 2 improvements: a new, non-jettisonable, 610 imperial gallon ventral fuel tank, and a new, kinked, conically cambered wing leading edge, incorporating a slightly larger leading-edge fuel tank, raising the total usable internal fuel to 716 imperial gallons. The conically cambered wing noticeably improved maneuverability, especially at higher altitudes, and the ventral tank nearly doubled available fuel. The increased fuel was very welcome, but the lack of cannon armament was felt to be a deficiency. It was thought that cannons were desirable to fire warning shots in the intercept mission. The F-6 was the ultimate Lightning version to see British service. These tanks were jettisonable in an emergency, and gave the F-6 a substantially improved deployment capability. There remained one glaring shortcoming: the lack of cannon. This was finally rectified in the form of a modified ventral tank with 2 Aiden cannons mounted in the front. The addition of the cannons and their ammunition decreased the tank's fuel capacity from 610 to 535 imperial gallons. But the cannon made the F-6 a real fighter again. The final British Lightning was the F-2A. This was an F-2 upgraded with the cambered wing, the squared fin, and the 610 imperial gallons ventral tank. The F-2A retained the AI-23 and Firestreak missile, the nose cannon, and the earlier Avon 211R engines. Although the F-2A lacked the thrust of the later Lightnings, it had the longest tactical range of all Lightning variants, and was used for low-altitude interception over West Germany. Export and further developments. The F-53, otherwise known as the Export Lightning, developed as a private venture by BAC, while the Lightning had originated as an interception aircraft. This version was to have a multi-role capability for quickly interchanging between interception, reconnaissance, and ground attack duties. The F-53 was based on the F-6 airframe and avionics, including the large ventral fuel tank, cambered wing and over-wing pylons for drop tanks of the F-6, but incorporated an additional pair of hardpoints under the outer wing. These hardpoints could be fitted with pylons for air-to-ground weaponry, including 2 1,000-pound bombs or 4 SNEB rocket pods, each carrying 1868mm rockets. A gun pack carrying 2 Aiden cannons and 120 rounds each could replace the forward part of the ventral fuel tank. Alternative, interchangeable packs in the forward fuselage carried 2 Firestreak missiles, 2 Red Top missiles, twin retractable launchers for 44 x 2-inch rockets, or a reconnaissance pod fitted with 570mm Type 360 Vinton cameras. BAC also proposed clearing the over-wing hardpoints for carriage of weapons as well as drop tanks, with additional Matra JL-100 combined rocket and fuel pods, rockets and 227 liters of fuel, or 1,000-pound bombs being possible options. This could give a maximum ground attack weapons load for a developed export Lightning of 6 1,000-pound bombs or 44 x 2 in rockets and 144 x 68mm rockets. The T-55 was the export two-seat variant. Unlike the RAF two-seaters, the T-55 was equipped for combat duties. The T-55 had a very similar fuselage to the T-5, while also using the wing and large ventral tank of the F-6. The Export Lightning had all of the capability of the RAF's own Lightnings: exceptional climb rate, agile maneuvering, and a hard-hitting punch. Unfortunately, the Export Lightning also retained the difficulty of maintenance, and serviceability rates suffered. The F-53 was generally well regarded by its pilots, and its adaptation to multiple roles showed the skill of its designers. In 1963, BAC Wharton was working on the preliminary design of a two-seat Lightning development with a variable geometry wing, based on the Lightning T5. In addition to the variable sweep wing, which was to sweep back between 25 degrees and 60 degrees, The proposed design featured an extended ventral pack for greater fuel capacity, an enlarged dorsal fin fairing, an arrestor hook, and a revised inward retracting undercarriage. The aircraft was designed to be compatible with the Royal Navy's existing aircraft carriers, carrier-based aircraft. The VG Lightning concept was revised into a land-based interceptor intended for the RAF the following year. Various alternative engines to the Avon were suggested, such as the newer Rolls-Royce Spey engine. It is also likely that the VG Lightning would have adopted a solid nose to install a larger, more capable radar.